Hello, this is lecture on metric system and SI system of measuring. So basically we'll go through difference between English and metric and a little bit of the SI unit of measuring. And as the cartoon says, if you cannot measure, you cannot do science. It's important that, especially in the physical sciences, that we measure correctly and project that measurements well as well. So first, the English system of measurement was developed obviously in England using old measuring units that were used all throughout Europe. These date back all the way 100 years to like the Roman times. So here's some distances that they would use: a fathom, mile, yard, foot, inch. And basically these are just arbitrary values that they came up with and they stuck around for 100 years. So for example, a foot was a mile was 1,000 paces a Roman soldier could do. So how long the distance 1,000 paces was. The length of a king's foot was the foot, and the width of the king's thumb was an inch. So those are measurements that are just basically arbitrary. A volume, the same thing. Queen Anne's wine container was considered a gallon, and then from there it would go from quart, pint, cup, and then fluid ounces. Weight is talking about tons, pounds, ounces, and weight. Here's some types of English units. You get conversions. 12 inches is a foot, 3 feet is a yard, 5,280 feet is a mile. Difference of volume: 4 quarts is a gallon, 42 gallons of petroleum is considered a barrel. A bushel is 32 quarts. So very random numbers, you'd think. And then on the metric side, you can see everything was simple in tens. Mass is the same deal. 16 ounces is a pound. A short ton was 2,000 pounds. A metric ton is different. It's 1,000 kilograms. But again, you can see the metric unit is very simplified with base 10. Temperature is basically the only thing that we can consider to be used in both. We don't really use Fahrenheit a lot. In the United States we do. We use Kelvin and Celsius a lot because it's an easy conversion. You can see Fahrenheit and Kelvin are a little more complicated equations to convert, and our base unit is Kelvin, and it's a simple conversion from Celsius to Kelvin by adding 273. So why is English system so difficult to learn? You can see that numbers there's so many different units there, with their feet, inches, yards, miles, and there are too many numbers to remember. 12 feet is 12 inches is a foot. 4 cups is a quart. All those different numbers are a lot of things to remember. And during the French Revolution, 1799, the French developed a metric system based on tens. There's 3 reasons why you should learn the metric system. The U.S. is the only major country using the English system. You can see from this picture the pink countries: USA, Liberia, and Burma, which I think is all using English units, where the green is using metric system. Number 2, it's base 10, so everything is moving the number by tens, so it makes conversions a lot easier, whether you're working with meters, liters, or grams. And you don't know a system of measuring. In science, measuring is an important skill. So when you're converting, it makes things easier and makes measuring easier as well. We already use the metric system. You can look at labels. For example, here you can see that you're working with milligrams of sodium. It's a metric mass, and you have two volumes. You have ounces, fluid ounces, and milliliters. So it's already converted for you, that basically you have 16.9 fluid ounces is 500 milliliters. And again, here you have other nutritional facts in grams or milligrams. You can see here on the water, 8 ounces is 240 milliliters, but everything else, grams, milligrams, you have metric system already. So here's a quick review of the different units that you will see, the main units for distance, volume, and mass, and how they were divided. So distance is a meter, and it's basically the volume is a liter, and for mass is kilograms. So for a meter, it takes about 10 million meters to go from the pole to equator. So it's 10 millionth of the distance is the meter. Liter is 1/10 of a meter on each side of a cube. And a kilogram is the mass of 1 liter of water. So that's how they were derived from the French. Kilo means 1,000, so it's 1,000 times of the base. Centi is 1/100th, just like a century is 100. 1/100th, or 0.01. And milli is 1,000th, or 0.001, which means millennium is like 1,000, so it's 1,000th of a year. Or a year is 1,000th of a millennium. Examples of a kilo, you have kilometer, kilogram, centimeter, and centigram for centi, and for milli, you have milliliter, milligram, and millimeter. So you can see here, meter, you have kilometer, meter, centimeter, millimeter, liter, kiloliter, liter, milliliter, and kilogram, you have all the different grams. So you can see that the prefix for all of them are the same. So that means you can use conversions really easily based on its prefix. So for length, basically a meter is the height of a doorknob. Liter is L, and the base unit for mass, gram. So for example, millimeter is about a grain of sand in distance. Centimeter is about a grain of rice. And kilometer is not really a mile, but it's basically using the same idea as a mile. Volume is milliliter, centiliter, and kiloliter. Mass is milligram, centigram, and kilogram. So again, prefixes all are the same, so it makes conversions easier. All right, measuring. So when you're measuring, you have a meter. You're measuring distance, how far apart an object is. So on a meter stick, you have the centimeter. The centimeter is each big number, and then in between each one is a millimeter, which 10 millimeters make up a centimeter. So a meter again is 1/10 millionth the distance from the North Pole to the equator. 1 meter is 100 centimeters and 1,000 millimeters exactly, so it's perfect about the metric system. And a kilometer is 1,000 meters, which is about 0.6 miles, 0.609 miles. The liter is the amount of space an object takes up as volume. A liter is 10 centimeters by 10 centimeters by 10 centimeters, which makes a cubic centimeter, 1,000 cubic centimeters, which is the same thing as milliliter. So a cubic centimeter and a milliliter are equivalent. You can see those uses back and forth. A liter is a little more than a quart, and the volume is 3D, so it's difficult to estimate. So it's even more important to be exact. Kilogram is the mass. Mass is the measure of how much matter is in an object. Weight is the measure of the pull of gravity. So weight is different on the moon and Earth, but the masses are going to be the same. So if you take a liter and fill it with pure water, the mass of the water is 1 kilogram. And the reason they use water because it was a common substance on Earth, which still is. And 1 cubic centimeter of water, or 1 milliliter, is the equivalent to 1 gram, which is the density of water, 1 gram per milliliter. So here's some other basic review. You have killi is 1,000, centi is 0.01, milli is 0.001. Okay. Alright, so we have a mass of a grain of sand. It would measure in milligrams. Very small distance to Washington, D.C., you would use kilometer. Volume of a pond, you would use kiloliter because it's very large. Width of the room, you would just use a meter. A volume of cup would be a milliliter. And a mass of a person would be in kilograms. So match the picture with the unit. So the measurement of a piece of paper, it's too big for a meter, so you use a centimeter. The width of a dime, very small, so a millimeter. Width of a classroom would be meter. Distance in the United States, traveling, you use a large number, so you need a kilometer. Distance to the mall, so you again measure in kilometers. And the width of a pencil, or the length of a pencil, again, pretty small, so you'd use centimeters. And the last one, the height of the old brick building, too small for kilometers, too big for centimeters, so you would use meters. Alright, so that is the end. Let me know if you have any questions, and we'll talk about more in class.